Hey there, fellow tech enthusiasts. Today, we're diving into a fascinating case study from the world of software engineering, how Stripe revolutionized their database remediation process. Now, you might be wondering, what's so special about fixing databases? Well, let me tell you, it's not just about the technical details, it's about the impact on the entire organization. So, buckle up as we explore how Stripe used graph search and state machines to automate this critical task, and why it matters for any company managing complex distributed systems. First things first, let's talk about the pain points. Before implementing this new system, Stripe was struggling with a hard-coded, plugin-based remediation process. It was like trying to navigate a maze with a map that only shows the way out, but not the path to get there. As the authors candidly admit, this approach had its limitations. It was fragile, with dependencies that were like a house of cards, ready to collapse at the slightest change. And when things went wrong, it was like a never-ending loop of pager alerts and manual interventions, blocking critical operations for hours. So, what did Stripe do? They decided to model their MongoDB infrastructure as a graph. Now, you might be thinking, what's the big deal about a graph? Well, in this context, it's like having a detailed map of your city where every street and building is represented, and you can navigate it with ease. By doing this, Stripe could identify valid recovery paths and adapt to different database layouts, like a chameleon changing its skin to blend in with its surroundings. And the results? Well, they reduced database-related pager alerts by about 30%, which translates to 200 fewer pages per year and 12 days of unhealthy shard states eliminated annually. Now, what makes this really interesting is how Stripe approached the problem. They didn't just use a simple breadth-first search, BFS, algorithm. They adopted Dijkstra's algorithm, which is like having a GPS that not only shows you the shortest route but also the most efficient one. By doing this, they could prioritize lower-cost recovery plans, reducing unnecessary operations while preserving correctness. It's like having a smart assistant that knows the best way to get you to your destination, even if it's not the fastest. But wait, there's more. Stripe didn't stop there. They realized that remediation should be more than just a series of fixed workflows. Instead, they modeled it as composable rules with explicit state transitions, enabling the planner to combine operations dynamically as infrastructure evolves. It's like having a flexible recipe book that can adapt to any kitchen, no matter how big or small. Now, you might be thinking, what does this mean for the rest of us? Well, it's not just about fixing databases, it's about how we approach complex distributed systems. For teams managing these systems, this pattern of state machine modeling, simulation-based planning, and runtime pathfinding offers a compelling alternative to accumulating ever more specific runbooks. Runbooks encode known recovery procedures, a state machine discovers novel ones. It's like having a team of smart assistants that can learn and adapt, rather than relying on a static set of instructions. And let's not forget the broader implications. As Scott McVicker, head of developer infrastructure at Stripe, points out, operating a global database fleet means accepting that hardware degradation and unhealthy shards are daily occurrences. At scale, the challenge isn't just fixing issues, it's doing so without burning out your on-call engineers. So, how can we apply these lessons to our own organizations? Well, that's the million-dollar question, isn't it? In my opinion, the key takeaway here is that automation isn't just about efficiency, it's about resilience and adaptability. By modeling our systems as graphs and using state machines, we can create smart, flexible solutions that can adapt to changing conditions and evolving infrastructure. And who knows? Maybe one day, we'll be able to automate not just database remediation, but the entire life cycle of our systems. So, what do you think? How can we take these lessons and apply them to our own organizations? Let me know in the comments below, and don't forget to like and subscribe for more insightful content like this. Thanks for watching, and I'll see you next time.